Yes, this particular session is for those students or for those people or those for working candidate who is always have a problem in understanding how SQL is behaving internally. Writing query is something called like you are limited up to writing the query and you are understanding only the overview. What is happening internal to the SQL if we write the SQL statements and we execute it, or how Oracle database text insight is this session is particularly explaining those things only, those internal SQL executions. Okay, so before going into the depth, I'll try to show you the Oracle architecture because this needs to be understood. It's not mandatory to understand it in full, in detail manner, but overview, you can look at this particular figure. Oracle architecture. The main memory of the main part of Oracle is the system global area, which we call it SGA. So our intention is to understand only the SQL part, how SQL is taken care by Oracle internally. So we'll focus only in this part. Within that, there is something called shared pool. Shared pool. These all are the memory area. Memory is very much important. The important things within any of the process, whether it is Oracle, whether it is Java, anything. If you know what is happening internally within the memory, then you can think in a more broader way. So within SGA, there is something called shared pool. Within shared pool, there is something called library cache. If we write any SQL in Oracle, this SQL will be stored into the library cache. This is the library cache. That's it. I'm not going to explain you all PMON, SMON, all 13 processes. It is not concerned with this particular topic. So I just wanted to make it resides into your memory so that you will understand what is happening. So we'll focus only on the library cache. Now coming to the SQL part. When we write, let me open the PLSQL, the developer. Let me connect to sys user first. Sys and sysdb. I'm using PLSQL developer tool to write the SQL statements. You can use any tools like Word, SQL Plus, anything, whichever you are comfortable. I have written. Let me connect to the another schema so that we can compare these two. I'm connecting to a Scott schema. The moment I write one query called select star from EMP and we execute it, what is happening internally? It will show me the data, but before showing the data, it has to go through a number of processes. Our intention for today's session is to understand what are those processes based on which Oracle fetches the information. So once we write select star from employee, the whole text select S in caps, E in lowercase, L is lowercase. This all the way I wrote the SQL statement, the same text will be stored into the library cache. First, before storing, we call it parsing. Means anything which we write within any compiler like SQL or C and Java, it needs to be parsed. Means we should write in the same syntax which the Oracle SQL understand internally. In place of select, SELECT, they have to write only SELECT. If you are writing in place of select some SELCT, then there will be a syntax error. That is normal practice. That is normal internals of any compiler. So first it checks the syntax. Before it checks the syntax, it will try to check whether the same select statement, the whole select statement is there in the memory of Oracle or not. Just now I showed you Oracle architecture. I have extracted that part, only the library cache part here in my PPT, this page of the PPT library. So the moment I write select star from employee, it immediately copied into the library cache here, select star from employee. Next SQL statement. The moment I write all the select word from word or the table name, all are in the capital letter or in the uppercase. The whole select statement is in the uppercase. It will try to check whether this particular text it actually consider it as a text. This text is already there in the library cache or not. No. Since we have executed select S in uppercase, rest or in lowercase, so whole select statement in uppercase will not match with the select statement. It is in lowercase. So it understands this differs from select star from AMP, there each letter are written in lowercase except S. Then this select star from employee where each letter are in uppercase. So these two, lowercase select statement and uppercase select statement, will not match. So it will insert again a select statement into the library cache. Okay, so it means Oracle internally behaves each SQL with respect to the lowercase and uppercase. Like if we write any, as I showed you, if we write any such select statement in uppercase or lowercase, it has to match again into the library cache. So the select statement in the lowercase and select statement in the uppercase is not same. Even the query is going to retrieve the same information, like same 14 records from the employee table. Okay, so the uppercase is matched with the lowercase, and it is saying it's not matched. So it will insert again the uppercase select statement into the library cache. So every time whenever we write a same SQL statement in a different fashion, like sometimes the people write select the first word of the Oracle keyword, the first letter of the Oracle keyword in uppercase, rest or in lowercase, like as I have written here, first S is uppercase. So different people have a different fashion of writing the SQL statement. So it is always advisable in order to follow the proper rule, so that it will not be passed again and again. It is always advisable to follow the same fashion, whether you are writing the SQL statement in uppercase or lowercase. Just stick to the one way of writing. Either keep every SQL statement in uppercase or either in the lowercase or in first capital letter. They call it init cap. Whichever the way you like, try to follow the same fashion of writing the SQL statement. So what is happening here? If we write the select statement as I explained you in the lowercase, the first time it checks whether the first time it is going to be executed, then it won't be available in the library cache. So what it will do, it will parse the SQL statement. In the next PPT, I'll explain you what is parsing. Parsing is basically syntax checking with other activities also. I am going to explain you. I will explain you in the next PPT. But here the matter of understanding is this particular SQL statements was not available in the library cache, so it moved from your terminal to the library cache. It is just copied over here. We call it hard parsing. If it is not there in the library cache, we call it hard parsing. Similarly, this SQL statement which I wrote in uppercase was not available in the library cache, so it again hard parsed. Okay. Again, I am writing a select statement in the same fashion I wrote it previously. See here, select S capital, everything remains the same. So it will check into the library cache and it found this is available here. So it won't pass, it won't make another entry over here. As we can see, there are two select statement entry. The third select statement entry is not made in the library cache. So we call it soft parse. Every select statement in the library cache is associated with something called hash value. Hash value is a unique key associated with each select statement. Oracle checks internally whether this hash value is already there or not. Okay, so what is the view which is used for seeing whether the SQL is in the library cache or not? SQL data dictionary view called v$SQL, which you can run from the sys user. Let us try to run the v$SQL and see what is happening internally. Let us try to run SQL statement by connecting to the Scott schema. Let us write one EMP where DEPT number is equal to 10. Wait. Let us check over here. I am just trying to fetch that because it has stored many records since the time I started this writing the SQL. Means when I downloaded the database, I installed it, it will try to cache all the select statement I have written so far. So SQL text, let us focus on that particular text or the SQL statement which we wrote now. Like I'll try to put where department number equal to 10%. See, this particular SQL statement now came to the library cache. Seeing the library cache information, we use v$SQL. So the whole select statement will be here. Right. So the next time, and I will try to write the same thing here. Select is in capital letter, start from EMP, rest all I wrote in the lower case. Let's see what is happening. Let us see, I can see that this particular selected statement is again stored in the library cache because Oracle says this statement and this statement differs. These two statements are not identical statements. So it has to go for the hard parse again. So as I advise you, it is always try to write the SQL statement in the same, in any of your, like every company has its own coding standard. So follow the same coding standard, and that is why companies make a coding standard for the developer. This is one of the reasons. Even you can see like it fetches the information very quickly, but if you can imagine within a day during the time the database, like the people are hitting the database like anything from the different application, then in that case how many different people, like different applications are hitting the DB, and each application has their own way of writing the SQL query. So even the same query is written in a different application, but in a different way, but in a different, like uppercase or lowercase, somebody has a mixed case. So the different fashion of writing a query will actually overhead the database, because each query, even it is same, identical, need to be parsed again. That parsing time will be very heavy if the number of SQL statements hitting to the Oracle DB is much more. The huge volume of select statement is coming to the database and hitting it. Even the same SQL statements are written by the different application will need to be hard pass. So it is always advisable try to reduce the hard pass. It is always advisable to follow the coding standard of your organization. So I hope you guys would have understood it. So let us focus on the other part of SQL internals. So as I explained you hard parsing and soft parsing, let us focus at more the granular level about parsing. What is parsing? In parsing, Oracle does 4 or 5 steps. Checking of syntax. First, the syntax needs to be checked as per the SQL compiler. Whether we have written the SQL statement is having the proper syntax or not. Okay. Checking the full checking the syntax, like first is checking the validity of the tables and columns from the data dictionary, verifies whether users are authorized to see those objects. We call it semantic parse. What is semantic parse? So semantic parsing is like, if I am a user, a Scott user, I logged in by Scott Tiger as a password, and I am trying to execute a table which is not owned by Scott user, like some other table from the HR schema, like some table called payroll is table name. So it validates and it checks whether this Scott user has is having the privileges to access this table or not. These all things will be checked. Or also, second thing, like if I have written a query table called employee and the employee table doesn't exist in the database, these all kinds of checks will be done there in the semantic parse. Loading of SQL in the library cache. The loading of SQL means the same thing as I showed you in the previous PPT. Like if you have written the SQL statement, before it is going to pass, it will check the whole text, like select a star from employee is a text with semicolon is a text. It needs to be checked against the library cache, whether it is available or not. Once it is said it is available, it won't go for the syntax parsing or semantic parsing. So our time will be saved during the syntax or semantic parsing, because only those SQL will be saved in the library cache only when it is parsed successfully during these 2 steps, like syntax parse and semantic parse. So once it is checked into the library cache, whether it is there or not, that depends. Now, suppose the SQL was not there, now it is stored in the library cache, then based on the statistic gather on that table, like every table has a statistic gathers, like we do it like analyze table compute statistic or DBMS underscore stat. This is a separate part. Just try to understand that statistic means as of now, what is the information with this table. Based on that information, Oracle will create the execution plan of that SQL statement. So once the SQL statement reaches to the library cache, Oracle will create execution plan of that statement. Based on the plan, it will execute or it will try to fetch the information in minimal time or minimal resources, like it won't utilize too much of CPU time, it won't utilize too much of input-output operation. So now the data is fetched by the SQL statements. Going to the next slide. We call it, what is the difference between hard parse and soft parse? As I explained you also, let me go through again. If the SQL statement is already parsed, means it is available in the library cache or shared pool, it is called soft parse. Okay, so we will be saving the parsing time. If the SQL statement is not available in the library cache, we call, then it has to be parsed. This has to go through all the four steps as I showed you here. This has to go through, that will take time, and finally it will be stored in the library cache again. Since the memory area allocated to the shared pool is finite, like everywhere, whenever we start an instance of Oracle, it occupies memory area. It occupies memory area into the RAM. Within the RAM, Oracle SDA. SDA is their system global area. Within the SDA, shared pool is there, as I showed you in the first PPT. So if the SDA size is, if the RAM size is suppose 1 GB, then we generally allocate like 5 MB or the 20 MB of the RAM size to the SDA. Within 20 MB, there is the size of shared pool area also. We call it generally, we call it like within 20 MB, you can assign 5 MB to the shared pool. Within 5 MB, if you keep on writing the SQL, suppose you have written some SQL at 8 a.m. morning today, and many people hit the database by using their SQL statements, like maybe 100 SQL statements have been written during the day. So in the evening, if you are coming and writing the same SQL statement with the same coding standard, like all are in uppercase or either all are in lowercase, then there may be a chances like your SQL statement which you executed at 8 a.m. in the morning may not be available at 8 p.m. because the shared pool is having a finite size. As I explained you, 5 MB of space. So whichever the SQL statement comes first will go first from the library cache also. So we call it, it is called first in first out or least recently used algorithm. This follows, Oracle follows to manage the library cache, the algorithm which is called FIFO or LRU. Then the first SQL which I have written in the 8 in the morning, and people keep on writing the SQL statement during the day. So there is a time when a new SQL statement doesn't have sufficient space to cache in the library cache. Then the first SQL statement which was written 8 a.m. will have to go from the library cache, so that the new or latest SQL statement will be there on the left side of the library cache. So it is always advisable to write the SQL in the same case which you have written previously, so that the soft pass will happen. So this caching of SQL in the library cache depends upon the way you write the SQL statement, also depends upon the shared pool size. So many people, generally the DBA guys, increase the shared pool size. So you came to know the reason of increasing the shared pool size. Why people prefer to increase the shared pool size. This is the reason. So we let us have a look, like briefly about like when we do the hard parts. There are a lot of works then Oracle has to do rather than doing the soft parse. So excessive hard parse can occur if the shared pool size is too small also. If you keep the shared pool size 1 MB and you know that there are many SQL statements will be written during the day and the size of shared pool is so small, then the new SQL statement has to be executed again and again, because it won't be available in the library cache because of minimal size set at shared pool. So what are those tables that Oracle uses internally in order to parse the SQL statement? This is the list I prepared, like system objects queries during the hard parse. See how many tables are there. Access dollar is the one table. Permission, what is the purpose of using this access dollar? Permission used by the dependent object against its parent. Means whether if you have rated select star from employee from the marketing schema, suppose there are three schema there in marketing, HR and HR schema. and the marketing guys is trying to write a query like select star from EMP. Obviously, the employee table, this marketing guys will not have permission to select any record against the employee table whose owner is HR. So it will checked by the access dollar. Whenever we create a table, that table is associated with the owner who actually created the table. That is stored in access dollar. I'm giving you overview. C calls, constraint column is specific data, like any constraint like primary key is there. So if you are trying to insert the data into a table which is having a primary key on a column, and you are trying to insert same data again into the same column, then it will throw you the error. Similar like this, there are many other, like up to I think 18 or 17 data dictionary views which are checked against during the hard parsing. So you can imagine how many tables internally checked by Oracle during the hard parsing. So if your query is there in the library cache that will go for the soft parsing, you can save your time to allow Oracle going through these tables. Okay, system object. So there are around, it is said like there are around 59 queries against the system object execute during the hard pass. You can imagine 59 queries, even like select star from EMP in lowercase. Again, we have written select star from EMP in uppercase. So even there is a small changes in lowercase and uppercase, Oracle has to go 59 queries. Oracle has to execute 59 queries against all the objects used in the query, like here employee. So it is also calculated like if your hard pass time is 0.06037 seconds, then you can reduce the time to make it soft pass by around 0.000095. How much is the difference? There is a drastic decrease in the time for one SQL. You can imagine like whole day if the different application or the different user, even including developer or any other user, have hit the database around 100 SQLs, so you can save the time of 100 SQLs. This is about one SQL. That will really improve the database timing or the database performance. This is very small, but it will make the small things, if you keep on added 100 times, that will make a big difference. I should explain you also how to view the SQL statements written by the different people, and it is stored in the library cache. How can you see the SQL statement stored in the library cache? This is the selected statement. We can query against $SQL, the dictionary. So even I'm showing you select star from employee where where department is equal to 10. Then select star from employee where department is equal to 10 in uppercase. Even it is going to fetch the same number of records. Department 10 is having suppose 5 employees, so 5 records. In both the select statement there are 5 records, but these two select statements have to be passed twice because of the case sensitive checks during the parsing. Even you write some comment sometimes. Sometimes we have written the select statement like select employee number ename from employee where department is equal to 10. After that we realize no, I need to show all the columns. So I commented out 2 columns here. So even there is a comment in the select statement, Oracle understand it a different select statement altogether. So this will also be hard parsed again. So although the above select statement returns the same record, Oracle will consider them to be different because lowercase letter differs from uppercase. Adding comment also makes SQL statement different. Every SQL statement will assign to a hash value we'll see here. So if we do select star from $SQL, what are the important fields I'm going to show you? SQL text, select star from employee where department is equal to 10. This is the actual SQL statement executed by someone. and every SQL statement will have a unique ID. The ID is something like this, and every SQL statement have a unique hash value. Oracle internally checks whether it is there in the library cache based on the hash value. These all are internal things. And the execution, how many times you have executed. If you executed the same select statement twice, then the value come under execution column 2. 4 times, then it will come 4 line like this. See, that's select statement, all comment 1, uppercase, lowercase, using bind variable, right? This is very, very important topic also, because the people don't know what is the advantage of using the bind variable during the execution of select state. This makes a lot difference in the performance of the SQL statement. Let us have a look on this. On the SQL prompt, we can define a variable called v_dept. Let us define it, the v_dept variable as a number type. Let us assign the value. This is the syntax to assign the value under v_dept column. Colon v_dept is equal to 10. Select star from employee where department is equal to v_dept. We call it one row selected. Oracle gives it. Now, what is going to happen here? This select statement will be passed and stored in the library cache. Select star from employee. Let us do it practically also. Come to the Oracle. Come to the command window. Call it variable v_dept is a number type. It is done. Execute. By using the exec statement, we can assign the value within the variable v_dept colon a_dept is equal to 10. You can see colon equal to 10. It is not like this. Colon equal to 10. Colon equal to 10. No need to give the semicolon because this is SQL plus syntax. 10 is done. Now we call it select star from EMP where DEPT number is equal to v_dept. v_dept semicolon. From, we have that in the wrong from statement. Select star from. Just copy. Put it there. They have to give set colon. So I show that we will learn by writing the syntax v_dept. This is executed and it returns 4 records. Let us assign the variable as a 20, department number 20, and execute the same select statement. Let us see what is going to happen. It returns 5 records with a different 5 records. Earlier with department number 3, there were 4 employees. With department number 20, there are 5 employees. What is happening internally in the library cache? Let us see. In $SQL, I call it, we can search it by using, one second, %v_dept colon v_dept. Let me check what is the value I set it here. Colon v_dept. Let's give a %. Here, this is the SQL statement. As you can see that it won't catch the SQL statement saying select star from employee where department number is equal to 10 Again, select star from employee where department number is equal to 20. So there are one SQL statement is used to execute the records of different department number. So we have seen the advantage of using the bind variable. If we would have used like something like this, we would have used something like this, select star from MP where DEPT number in, check the difference, 10, 20. See here in the library cache. One second. SQL text like select star from, we call it where department number. Let us select only this. See here. How many times one SQL statement is executed here? Because of that, it internally creates, suppose this is said like this, whenever you are trying to write a select statement with department number in 10, 20, rather than storing it into the bind variable, the big difference is when you write a SQL statement by using a bind variable, even with the different where condition you assign to the bind variable, it is going to be cached only once. So hard parsing will not be done for 10, 20, and 30. But when you write a SQL, you can see there is only one SQL ID or hash value. They have seen there also. But when we write a select star from employee where the department number is 10, 20, there would have been 3 hash values and each time SQL statement would have been passed for department number 10, 20, and 30. That is the big difference. So instead of writing 10, 20 department number in 10, 20, 30, better you pass the bind variable to the SQL statements so that there won't be the too many hard parsing done for each of the department number. Okay, I hope this is clear to all of you. We'll start tomorrow a new session called buffer cache of SCA. We have seen so far like how SQL statements are parsed internally, how SQL statements are cached internally, how SQL statements can be written so that we can reduce the number of hard parsing. Once the SQL statement is ready, syntax parsed, everything is done, cached into the library cache, they have saved a lot of time during the hard parsing. They have tried to reduce the hard parsing time. Now the time comes to fetch the information from the database. All the data of a particular SQL statement fetched by the SQL statement, how it behaves internally within the Oracle memory. Then we will look into the buffer cache. They have seen library cache is used only for the SQL statement parsing. Similarly, the buffer cache is used for the data, how the data is managed internally. How can we cache the data? By using the Oracle log, the smallest unit of the database. Okay, we'll see it later tomorrow in the tomorrow session.